tiny little singularity of space and time blew up to create the galaxies, the planets, the stars, you and me.
After the Big Bang, matter and energy spread out across the universe, where the force of gravity pulls it together into dense clumps. Intense pressure ignites fusion reactions that transform those clumps into shining stars. Then 4.5 billion years ago, our sun and the planets around it take form. This is early Earth. It's a place you would hardly recognize. You couldn't survive a moment on its 1800 degrees centigrade surface. As things cool down and oceans condense, the first bacteria, the first life appears.
From the early stages of life, certain organisms learn to access energy from the sun through the process of photosynthesis.
These bacteria begin to pump something into the atmosphere that will make human history possible on this planet. Oxygen. Then, after almost 4 billion years of life on Earth, in a sudden flurry of evolutionary change called the Cambrian explosion, life as we know it bursts into bloom.
By the Cambrian explosion of 600 million years ago, the record in the rocks of the Earth reveals a huge array of multicellular organisms. And thereafter, evolution picks up more and more quickly.
"500 million years ago, plants such as ferns and mosses begin to colonize the land. It's the first wave of vegetation that will grow to include all the crops and trees that we'll use to build our civilization. Then come animals, like amphibians. Life explodes in diversity, laying the groundwork for everything we know today. As all this is happening, the land itself is always on the move. continents drift across the planet's surface. Eventually, they take the familiar shapes on which human history will play out. Africa and India start crashing into Eurasia. And as part of this great collision, the mountains of northern Africa and Spain, and the Alps and the Himalayas rise. Two great rivers, the Tigris and the Euphrates, begin to flow. The Persian Gulf and the Red Sea thrust far into the land. And a region we call Mesopotamia comes into being. A region that will play an outsized role in the great drama of civilization that is to come. And so the stage is set for the rise of civilization. It begins in Mesopotamia 10,000 years ago, when people there figure out a new way to harvest deep time's greatest gift, the ancient energy from the Big Bang, which cooled into matter that was gathered up by gravity into our sun. There, extreme temperatures and pressures initiate nuclear reactions that release energy and radiate it to Earth as life-giving light and heat. Plants store this energy as glucose. Then herbivores access that glucose by eating plants. And the carnivores access that energy 2 steps on by eating the herbivores.
The story of the universe, the story of life, in fact, is a story of energy. Believe it or not, all the energy that we consume on the Earth today, our cereals and our bacon and eggs, originally came from the Big Bang.
As humans evolved over hundreds of thousands of years, we harvested this energy by simply hunting and gathering.
For 99% of human history, we basically lived as nomads, chasing the deer and the buffalo, getting energy from wherever we could. When the deer and the buffalo left, we had to leave too.
But about 8,000 BC, in a few select places, some people begin to experiment with a new way of harvesting energy. They're growing their own crops. An act so seemingly simple, it's hard to believe it will kickstart a revolution. But it will. These are the first seeds in the rise of civilization. And at first, it is only happening in one region on Earth, here in Mesopotamia. Why? A major reason is that the hills above Mesopotamia provide the motherlode of native plants that can be cultivated, including several species of a plant that's going to become mankind's most vital resource for all of recorded history. A plant whose roots go far back into deep time. Which plant is it? It's grass. It's not an exaggeration to say, no grass, no civilization. Around the world, every major civilization has been a collaboration between humans and a particular grass. Millet in North China, rice in South China. In Mesoamerica, corn. In the Middle East, wheat and barley. You don't get civilization without grass. For most of deep time, grass didn't exist. It first arises about 100 million years ago, when certain plants evolved to spread their pollen in a new way. Not through bees or other insects, but through the wind. But once it appeared, grass carpeted the planet.
Grass has the ability of being able to spread relatively quickly into ecologies and environments and populate them quite fully.
And here's where the forces of deep time help determine where civilization began. For one thing, the hills around Mesopotamia happen to have two kinds of wild grass that are easily cultivated and highly nutritious: wheat and barley. So early farmers here have a major advantage over people elsewhere on the planet.
But they still had work to do. So over the centuries, they took an early version of local wheat and they carefully selected it for the traits they wanted. One of those traits is larger seeds. Another is what's called non-shattering seeds, so that when the wheat is harvested, the seeds don't fall off and get scattered and lost. So slowly, over time, by careful selection, humans coaxed this to evolve into this.
And it wasn't just local grasses that could be tamed. Wandering the hills of Mesopotamia, our lucky farmers would have seen the ancestors of modern cattle: goats, sheep, and pigs. A collection of creatures that happened to have the right stuff to be tamed. Instead of hunting them for their meat, farmers could learn to raise them, ensuring easy, reliable access to animal protein for the first time in history. But why were these animals all found in Mesopotamia? Part of it was sheer luck. But another part was that deep time placed Mesopotamia at one of the vital crossroads of the world. As plate tectonics assembled the Old World, Mesopotamia found itself in the sweet spot where Asia, Europe, and Africa came together. Any wild animal migrating in any direction was likely to come through here. And if it liked these conditions, it stuck around. But what exactly is it about this collection of animals in ancient Mesopotamia that meant they could be domesticated and help humanity launch our first civilizations? Have you ever thought about why some animals became farm animals and others didn't? The first part of the answer is that all of our farm animals are plant eaters. And this is key.
It's way too expensive to keep and feed animals that eat other animals, much less one that might view you as lunch. So, if you're looking for an animal to domesticate, pick a herbivore.
But just because an animal eats grass doesn't mean it can be domesticated. When was the last time you saw someone plow a field with a zebra?
Some animals are simply untamable, they're too aggressive.
What else do cows, goats, and sheep have in common that make them tameable? They're all herd animals that will sometimes even stampede in their eagerness to follow a leader. take that instinct, substitute yourself for the natural herd leader, and you're on your way to turning a wild beast into a very useful animal indeed. But of the hundreds of large mammal species on Earth, only 16 will submit to a human being leading the herd. And so it's truly remarkable that among the select group, 4 of the most important animals that can be domesticated happen to exist in one small region of the ancient world. So thanks to favorable wild crops and animals, it is here in Mesopotamia that humankind begins the journey to farming, which is the key to the civilizations and empires to come. But this still leaves the question, why now? If fully modern humans had been around for 100,000 years, and farming just started 10,000 years ago, what on earth were we waiting for? It turns out we were waiting for warmth. 2.6 million years ago, an era of ice ages begins, producing distinct cold eras punctuated by periods of warm interglacials. Modern humans evolved during the last glacial period. And when did it end? You guessed it, 10,000 years ago. The fact is, plants like warm weather. And it was only 10,000 years ago, when the most recent ice age ended, that conditions in Mesopotamia finally came together in just the right way.
If you want to produce rain, you need a growing season that's at least 90 days long. You need summertime temperatures in the mid-20s Celsius. You need it slightly cooler at night. And you need abundant but not excessive rainfall. It's at the point when we see the glacier start to retreat last time, about 10,000 years ago, that we start seeing the beginnings of agriculture.
So climate change helps answer the question of why farming started when it did. Now, flash forward from 8,000 BC to 3,800 BC. People in hills above Mesopotamia have been farming for over 6,000 years. And things have been going pretty well. But a disastrous change is coming.
There was a general drying out. You didn't have as much the annual rains and floods. There were hotter temperatures overall.
A climate crisis that starts around 3,800 BC threatens to wipe out Mesopotamia's ideal conditions and bring the farming experiment to an end.
The Sahara Desert advanced into former grasslands. And what we essentially see are the early agriculturalists needing to innovate. They need to adapt.
And it turns out that ancient geology will be a key to their survival. "100 million years ago, As part of the endless process of continental drift, Africa and India begin drifting north, crashing into Europe and Asia.
The collision of Africa and India with Eurasia pushed up a series of mountains known as the Alpine Belt. This includes the mountains of northern Africa and Spain, and the Alps, and the Himalayas, and the mountains of Indonesia. And we think of these as different mountain ranges, but they're all connected physically because they were caused by the crashing of Africa and India into Eurasia.
And these mountains are crucial to the rise of agriculture, because moist air passing over them is forced to rise, where it cools, condenses, and falls as snow. Then, during the hot, dry summer months, the snow slowly melts. This feeds major river systems, just when farmers need the water.
So without these tectonic collisions, without the creation of these mountain ranges, we wouldn't have these tremendous river systems that have been so vital for subsequent human history.
Here in Mesopotamia, two of these Alpine Belt rivers, the Tigris and the Euphrates, flow down right into this region of early farming. Now, in 3800 BC, as this region dries out, these rivers allow people to create one of humanity's most important inventions, a key stepping stone to civilization. They begin to channel the rivers into a maze of canals and ditches that soak their fields throughout the summertime. Now they don't need rain, which has become erratic and unreliable. Now all they need is the river.
We can just imagine these early experiments in sort of ditch digging that must have gone on. Early on, this is done on a very small scale. And these villages are maybe 10, 20, 30 families, something like that.
People here have stumbled onto a solution that not only saves farming, but causes yields to explode.
Now, thanks to irrigation, there's a major food surplus. So for the first time in history, some people do not have to spend their entire lives obtaining food. They can devote themselves to making things like sun-baked bricks and clay pots. In other words, now some people can specialize.
Very quickly, these initial professions explode. Arguably, pottery is the first sort of profession that appears because everybody needs to store their stuff. You need stuff to eat out of and drink out of and so on. All the things that these early towns need now start to appear. And suddenly you've got builders, you've got tool makers, irrigation diggers and bricklayers and so on. Early priestly sort of classes begin to appear. People with specialized leadership functions start to appear.
As this happens, another new thing appears for the first time. Here in Sumer, the village of Uruk mushrooms into a hub of thousands of people. The first city. And the more people gather together, marshalling the energy of the surrounding countryside, the more complex human society becomes. It's a phenomenon seen across all scales in the universe. The more matter and energy gather together in one place, the more chances there are for new interactions, for new acts of creation. Whether it's dust and gas, pulled together by gravity into stars and solar systems, or elements gathered together into molecules. These hubs of complexity are what drive the universe forward and make it an interesting place to live.
The idea of hubs being regions of complexity where interesting things can happen permeates even life. Animals and plants could not have developed had it not been for a lot of stuff coming together and being present in about the same place.
In the emerging cities of Mesopotamia, complexity brings new challenges. People must find a way to prevent crime, resolve disputes, and pass laws. So in 3500 BC, the first large governments appear on Earth, a collection of city-states called Sumer, right here on the banks of the Tigris. Each city is ruled by a king and an elite of priests, scribes, and soldiers. These men establish laws, punish criminals, and provide order. This stability and structure helps civilization to grow. But these elites also tend to prey on their subjects. So now you get hierarchy. Using the same principle by which farmers herd cattle, people begin dominating other people.
We clearly see a leadership elite on the top. Below that, there will be what appears to be a military class, sort of the second tier. Then we'll see the great mass of peasant farmers, and eventually, as conflict increases, we'll see slaves.
This whole process of civilization, farming, irrigation, cities, hierarchies, begins in Sumer around 3500 BC. But it doesn't stay isolated here for long.
We know just a few centuries later, along the Great Nile Valley in North Africa, the second great civilization will appear, that of ancient Egypt. Further to the east in the Indus Valley, essentially modern Pakistan today, the third great civilization appears. Much further away, on the eastern end of Eurasia, there is another civilization. Initially along the northern river of China, the Great Yellow River, the Huanghe, another hub is appearing.
So far, all four ancient civilizations cluster in river valleys. The reason is simple. Early agriculture is just too primitive to create a food surplus on rain-watered land. Irrigation is still the only way to go. But humanity is about to break its dependence on rivers. Because around this time, people discover that some of the animals they first domesticated for food have another gift to give. The gift of power. Human beings are relatively weak. Over periods of sustained exertion, we can generate about 75 watts of power. And for thousands of years, we had to rely on our own muscles to get things done. Imagine today if every time you needed to switch on a light and keep it glowing, you had to turn a crank like this. It does the job, but it takes a lot of time and energy. Well, it turns out that human muscle is enough to farm rich river valleys that become naturally fertilized every year.
If I stay on a riverbank, which floods every year and brings new soil fertility every year, I, even as a weak, puny little human being, will be able to produce a high level of crops, a high yield on a riverbank.
But rain-watered land needs something else to keep it fertile year after year. You need to dig down and turn the soil over to dredge up rich nutrients. In other words, you need to plow. And people, with their 75 watts of power, are just too weak to do that on a large scale. But around 3500 BC, people discover that they can train some of the animals they've been raising as food to pull plows and dredge up the soil's deep fertility.
You could go down 6, 8, maybe even 10 inches in some cases and access a huge amount of soil nutrition, which allowed us then to produce much greater crops and much higher yields. And we could move into areas that simply could not support agriculture when we were simply using human labor as the basis of the cultivation.
It's an energy revolution. By yoking a horse or an ox to a plow, mankind multiplies his power 4 to 8 times. Civilization is liberated from the trap of ancient river valleys and begins to spread. Now, for 1,000 years, the area around Sumer will produce a stream of new city-states, each with their own governments and elites. Then in 2350 BC, a powerful new leader appears. He sparks a revolution that will reorganize civilization, giving it the form it will take in most places right up to the 20th century. A form we call the Empire. His name is Sargon of Akkad.
The great Sargon of Akkad comes along, conquers each of these cities one by one to create a much larger socio-political military structure, the world's first true empire. And this just becomes the standard model then for the next 2-3 millennia.
Sargon's forced unification of Mesopotamia into the world's first empire is violent. But once the violence subsides, the benefits become obvious. This region was physically blessed by the forces of deep time. But the hubs of energy were scattered across the landscape. Uniting these individual cities into empires is like networking a bunch of individual computers together. It multiplies their power and increases the exchange of goods, services, information, and ideas. Huge amounts of labor can be mustered to irrigate more land. Trade can move safely across vast areas. And since petty local wars come to an end, empires bring arguably their greatest gift: peace. Not far away, on the Nile, a similar process has been taking place. As god kings, called pharaohs, extend their rule across Egypt. Egypt's system is such a success, it becomes the most stable civilization in history, lasting almost unchanged for 2,500 years. But can deep time help explain why Egypt will be so stable and unchanging? Rise up above the Great Pyramid and look around. 2,000 miles to the south, the Nile begins in the mountains of Central Africa. "300 miles to the north, it empties into the Mediterranean Sea. On either side stretch harsh deserts. All of this is a function of how Africa crashed into Europe, a process that began 100 million years ago. And a byproduct of this deep-time geology will help Egypt's rulers keep their land united for millennia. One major reason for this has to do with travel and communication. In the ancient world, early boats can easily float down most rivers. But they're too primitive to sail back up, making most rivers a one-way street. But not so in Egypt. To the north, over the Mediterranean, cool winds blow south to replace hot air rising over the desert, creating a powerful breeze that never stops. So here, boats that float down the Nile can sail back up, pushed by the continuous breeze.
It's very easy to make the return journey and just come back down again. So trade and exchange, connections, if you like, between Upper and Lower Egypt are facilitated through geology.
Meanwhile, deserts on either side act as great walls to protect Egypt from invasion.
Here's this Nile civilization sealed off through its quirks of geology and geography, enjoying millennia of relatively uninterrupted, peaceful, successful civilization. Quite extraordinary.
In northern India, another new culture, called the Harappan civilization, begins to spread along the Indus River Valley, laying the foundations for the great civilizations of India. And finally, along the Yellow River in China, a fourth great civilization is taking shape.
The same basic pattern repeats itself in China at roughly the same time. It starts building cities, it develops agriculture along a similar pathway in terms of having large-scale irrigation networks.
But thanks to a quirk of deep time, China will forever develop as a world apart. Egypt, Mesopotamia, and North India are relatively close together. So these three civilizations are linked together in a huge cultural matrix. But deep time has separated China by 3,000 miles of Alpine Belt mountains and deserts.
Think about the journey you'd have to make to get from China through various deserts, the enormous mountain ranges, all products of the tectonic collision of India with Eurasia. You'd have to get through the highest mountains on Earth to be able to then send your caravans eventually down into the Indus Valley, let alone to Mesopotamia and Egypt.
China's isolation is illustrated by a major difference between East Asians and everyone else on Earth. And it has to do with how people write. In both the Middle East and in China, writing begins as pictographs and hieroglyphs, in which things and ideas are represented by thousands of individual characters. But Middle Eastern scribes eventually reduce writing to a mere 30 phonetic symbols, or even less, making it very simple. Phonetic alphabets are quickly copied across the Middle East and India. But thanks to their Alpine Belt isolation, the Chinese are unaware of this. So even today, throughout the Far East, people still have to memorize thousands of different characters in order to read and write.
Geographical isolation leads to the emergence of two profoundly different ideas about what writing should look like. Both equally rich, both capable of incredible expression, but both profoundly different, it appears, in purpose and in actual structure.
Despite being unaware of the other three ancient civilizations, China still exists on the same landmass as they do. So some things inevitably get through. Take a crop that is actually Chinese, the orange. The wild ancestor of all orange trees comes from South China. But it didn't stay isolated there for long.
Oranges, which start in China, end up all over Eurasia, and by the Roman times in the Mediterranean. So presumably there were trading routes, one little bit at a time. Farmers that tended to walk and hand seed over to their friends, that walked and handed seed over to their friends. And over very long periods of time, there were some exchanges between these two broad areas.
Across Eurasia, this happens again and again, with food, technologies, even ideas. Each great civilization reaps the benefits of everyone else's innovation. So for the next 3,000 years, all four great Old World civilizations will march forward at roughly the same level of development. But things will play out very differently for the civilizations arising across the Atlantic Ocean in Central and South America. American civilizations that culminate with the Maya, the Aztecs, and the Incas independently invent agriculture, then build impressive cities and empires. They create stunning art and architecture, and invent novel forms of writing, and amazingly accurate calendars. But even still, they're cut off from major advances that sweep the Old World. They don't have things like wheeled vehicles, or steel weapons, or gunpowder, and so they will lag thousands of years behind the people in Afro-Eurasia. Can the breakup of the ancient supercontinent Pangaea help explain why the Old World got a jump start on the Americas? Pangaea begins to break into smaller pieces 175 million years ago. But they're all different sizes.
Big chunks break off, much smaller chunks break off. They go in different directions. Eventually we end up with what we call the Eurasian landmass, if you like, which is a very big chunk of continent, enormous. Once India and Africa also drive into that landmass, you've got this vast world zone that we'll call Afro-Eurasia.
At almost 33 million square miles, Afro-Eurasia dwarfs any other landmass. And humans will discover that for life in general, and civilization in particular, size has its advantages. Because it's so big, Afro-Eurasia has the most plants and animals, the most river valleys, and the largest temperate zone. Civilizations here have a lot to work with.
There was a lot of different resources potentially available within Afro-Eurasia that could then gradually spread.
Even today, 85% of the human race lives in Afro-Eurasia. This double continent also has another advantage inherited from deep time.
Most of Afro-Eurasia is spread in the east-west direction. And so crops that developed at one latitude could spread along a band that would get about the same amount of sunshine, about the same climate.
The same is true for technologies and even ideas. So every civilization in Afro-Eurasia advances at roughly the same pace. But compared to Afro-Eurasia's 33 million square miles, the second largest chunk of Pangaea, the Americas, is only about 16.4 million square miles and lacks the diversity of the Old World. As far as the grasses were concerned, the early Americans had no wheat, no barley, no rice, no millet. The only major grain in most of the Americas was corn. And they had a similar problem with major animals. There was no draft animal, nothing you could use for a plow, nothing you could use to pull a wagon. Even more challenging, the Americas are aligned north-south, not east-west. This creates radically different climate zones. Crops and even people that grow used to the climate of North Dakota probably won't do well in Panama.
Even today, if you were to take a road trip from, say, Alaska, right, to Chile, think of the range of environments and different geologies and so on you would have to pass through as you do that.
Still, as civilizations first arise in both the Old and New Worlds, the amazing thing is not how different they are, but how alike. By 500 BC, the Old World civilizations have begun to spread from their original hubs of the Middle East, India, and China. They'll eventually link together into a vast worldwide system. That system was rooted in history's greatest revolution, the invention of farming, which still underlies our civilization and our success today. In one sense, the rise of civilization began 10,000 years ago when Mesopotamia's people began farming. But in another sense, agriculture and civilization have roots going back much further. To the evolution of plants like grass, and animals like sheep, goats, and cattle. To the tumultuous sweep of climate change, the birth of rivers, the rise of mountains, the collision of continents, the formation of the solar system, the energy of the Big Bang itself. In short, the whole immense saga known as deep time.